Hi there, and how is everyone doing? Welcome to yet another session on my channel. And today we're going to be talking about a comprehensive overview of machine learning concepts and techniques. It's quite a short course that I took on Allison Learning Platform, and I have just summarized a bit of the most pressing concepts, like for easy explanation and understanding. So yeah, don't take long. And definitely I will go through when you come to know the machine learning field. This is just a field of study where computers are given the ability to learn without explicit programming. Like they learn on how to control themselves. Yeah, basically that is it on a layman's overview. And the goal here is to use historical data to improve prediction accuracy and on unseen prediction accuracy on unseen data. As we all know how machine learning stroke AI works on helping machines use previous data on performing future tasks. And machine learning specifically has two types, that has supervised and unsupervised learning. And the best case story of this all is the best idea of this all is like we have models, and the simplest way we can term a model is a representation of a specific phenomenon. And they can be deterministic models or probabilistic models. For deterministic models, we hypothesize exact relationship that is used to predict, like used when prediction error is negligible. And for probabilistic models, we hypothesize two components, that is the deterministic part and the random error part. So we can have a term known as regression modeling. And in this regression modeling, it takes steps for us to get to uh, a finished model. One of it is hypothesize the deterministic components, let's say the features of the data set we have, and then we specify the probability of the distribution of the of the random error term. Then we evaluate the fitted model. That is how we come in with algorithms that check the accuracy of the model. Then to know how better our model is, we use this model for prediction and estimate. That is when the model goes in the outside environment to we test it on real world data to see if it is effective or if it is doing what we expect it to do from the data it has learned or from the training process. So furthermore, linear regression or and best fit, this is all the processes I had said. We go through while learning our data, we can say data engineering or EDA, to train the models to perfect. So the linear regression function assumes a straight line relationship between dependent and exploratory variables. Whereas for the least squares method, the primary tool of the finding the best fit is the least square method. So the the best way to we can define a best fit, or the importance of a best fit, is the minimizing of the difference between actual values and the predicted values, to to reduce the error that would the maximum error, possible error that we could get is if we minimize that difference between the actual value from the predicted value, so that we know how best our model is performing, and if it is ready to go outside there to do the jobs. So I really don't want to take. So basically, there are two types of models, that is parametric versus non-parametric. So in this one, you know exactly which model will fit in the data, and it is best for supervised learning, whereby for supervised learning machine learning type, whereby we have labeled data. That's why we know exactly which model we pick, because our data is labeled. So the model does not have to go to guess the features of the data because they're already labeled. And for non-parametric or key nearest neighbor, the data itself tells you what the regression should look like. So the model, this is on it's non-supervised learning in short, because here the model is just guessing, clustering features of different images, putting them together to come up with a complete complete, model that does it. It's more of like a lazy learner because it performs no training and simply stores the data set. So these are one of the ways as we are training, or the process of training these models, we have distance metrics, mostly, especially in the key nearest neighbors, because we deal in distances more. One of the ways we can measure the distance is through the Euclidean distance, whereby we identify similar properties between samples, and the Manhattan distance, which is identifying between the similar distances. And the K factor involves computing distance between the test training samples and to find the closest neighbors. Another concept of machine learning, we have decision trees. We can call them like another way of feature engineering, or determining which features should be considered for the model training. And these include some terms like Gini impurity, which values the range. These are all discussion equations that are used to calculate distances between features or mission battlefield. And entropy values range from 0 to 1, and this Gini impurity from 0 to 0.1. So the nonlinearity of the decision trees are excellent for capturing nonlinear relationships that simple regression might miss. So in one ways of avoiding overfitting in trees sensitivity, and pruning and post-pruning. So there we go through to ensemble learning and random forest. These are some of the algorithms we can say that are used in training. So ensemble concept is like combining many weak models to create one supermodel. We should come in with the bootstrap method, collecting information about the population from a sample to create variable training sets. So we have also support vector machines. And in this concept, its goal is to maximize the margin between classes. Yeah. So when you find the kernel tracker that transforms data into a higher dimension to find separate hyperplanes. So the hyperparameters, or the gamma of the support vector machine, can be there is to control influence of the training points. So in other words, high gamma influences points far away, leading to high variance or overfitting, whereas low gamma influences only close points, leading to high bias. So another algorithm we have here is K-means clustering characteristic. Clustering is here we gather together for unsupervised learning. We use this method to put together features with some similarity. So yeah, that's the whole story behind clustering. So for this, the popular linear algorithm for unsupervised grouping, and it's simple and easy to understand. That's why it is more used and popular. And it only requires it is only applicable of if we have the mean of the mean defined for the data we have. And some of its limitations, it's sensitivity, highly sensitive to initial seeds or outliers, and it doesn't work if it has a geometric constraint, that is spherical shapes, or if we don't have the mean. So lastly, the last concept of this machine learning course was principal component analysis, which its core goal is to the dimensionality reduction with minimal information loss. And it assumes that variables are linearly correlated, so not quadratic stuff. And it considers lossy compression because insignificant components are discarded. one of where it can be applied or its application or interpretation is interpretation challenge and facial recognition, reprocessing to mention but a few, like there are four of them. Anyway, so thank you for for listening through and yeah, this is all I had for us till the next session. Thank you very much and have a great time.